Well, I'm Martin Sweeting. I'm Executive Chairman of SSTL and also Director of the Surrey Space Centre. Actually, SSTL spun out of the Surrey Space Centre in 1985. At that time, it was a very small research group, and we needed to have some funds to continue building small satellites. And so the sensible way to do that was to spin out a small company. So we started with 4 people and £100, and over the intervening years, we've now just touching 500 people with about £100 million turnover. Starting out with such a small team where we built some of the parts of my kitchen table, we made a clean room from B&Q over the weekend. We have grown into something quite amazing. We now have our own dedicated building which has inside advanced manufacturing capabilities, test facilities and a large integration hall where we can assemble half a dozen satellites at the same time. In the 1980s, small satellites were considered very much a rather strange approach. And they were not popular, and people did not think that they were going to have any real utility. They were perhaps interesting for research and education, but not for serious jobs. In the intervening 2 decades, small satellites have developed dramatically, and indeed now you can almost say they've become fashionable, and they form now the sort of second highway into space. We have large satellites for those applications that require them, but increasingly small satellites become increasingly advanced and higher, more capable, and they are providing alternative ways of addressing many different applications in Earth observation, communications and science. From our very small beginnings in the university, the company grew. Initially, we used the laboratories on the university campus, then we developed our own Space Centre building with proper clean rooms, and then of course we outgrew those over the years and eventually moved on to the University Research Park, leaving the Surrey Space Centre behind to use those facilities for its own research missions. Also, in these new large facilities, we're building 22 payloads for the European Galileo navigation constellation. Throughout that period, we also carried out a number of specific technology demonstration programs, microsatellites carrying new payloads for the US Air Force Space Test Program, for European industry, and indeed for our own missions. We had our first mini-satellite, USAT-12, which demonstrated many of the technologies and techniques that we then went on to use in our more advanced Earth observation constellation satellites, and very specifically in the first Galileo satellite, GOVA. So the company retains very close links with the Surrey Space Centre because it's the research that's carried on there that provides the innovation and drive for new products. They're looking at a whole range of different technologies which we will develop over the next 5, 10, 15 years to provide the future products for the company. As well as SSTL's own technology demonstration missions like USAT-12, we also produce some very tiny spacecraft, the first of which was launched in the year 2000, was called SNAP, Surrey Nanosatellite number 1. It was actually a really sophisticated tiny spacecraft weighing just 5 kilos, which had on board autonomous orbit determination. It had onboard propulsion and a machine vision system which imaged a Russian host satellite in orbit. 10 years later, we're now working on a much more sophisticated tiny satellite called Strand, whose avionics are based around essentially a smartphone as the brain of the satellite. And this is going to be a step into the next stage of development where we're going to use multiple tiny satellites which will rendezvous and dock together in orbit in different configurations. And this is some of the research that's going on in the Space Centre, looking at the next generation of space telescopes beyond the James Webb Space Telescope, where we need to assemble the optical elements in orbit from a series of small satellites launched in clusters. SSTL has now launched 39 small satellites into orbit. The early missions in the 1990s focused on low Earth orbit communications, technology demonstration, and then gradually developing more sophisticated Earth observation cameras, until in the 2000s we formed the Disaster Monitoring Constellation, which was the first operational constellation of low Earth orbiting Earth observation satellites specifically designed to help monitor and help mitigate the effects of natural and man-made disasters. The vast majority of our business is actually international. Not just supplying satellites to customers who want operational missions, but also those countries wishing to take their first steps into space, where we have a know-how training and transfer program allowing 15 or 20 of their engineers to come and spend a year with us and go through the whole process, from initial design through manufacture, assembly, integration, test, launch and operations of a satellite, and get a really deep understanding of what space is all about. They then go back to their own countries and in many cases form the nucleus of new space agencies. Tech DemoSat 1 now provides an up-to-date opportunity for UK industry and academia, and indeed even schools, to participate in space, trying out their new ideas and new products so that they can gain the heritage to give them an advantage when trying to enter the international marketplace, which we very much welcome and we hope is going to be the very first of a series of UK national technology demonstration satellites. Tech DemoSat 1 carries an experimental sea-state payload, which is going to be the forerunner for the instrument that we're going to carry on the new Novasar radar satellite, which is being supported both by UKSA and TSB.
Sir Martin Sweeting there, with a brief history of an absolutely classic example of a successful technology spin-off from a university department, and talking also about the company's latest project, which is called, as you've gathered, the Tech DemoSat